Hello and welcome to the session. In this session, first of all, let us discuss measurement of probability. Now, the probability of an event denotes the likelihood of its happening Now, the measurement of probability means a measure of uncertainty. Now, let us discuss the probability scale. Now, the probability of an event E is denoted by P of E and P of E takes the value from 0 to 1. That is, probability of an event E is greater than or equal to 0 and less than or equal to 1. Now let us discuss certainty of an event. Now, if an event E is sure to occur or certain to happen, then the probability of the event E, that is P of E, is 1 or 100%. In other words, an event associated with a random experiment is called a certain event if it always occurs whenever the experiment is performed. For example, if you drop a pin, it will make a noise. Sun sets in the west. So the probability of both these events is 1. Now let us discuss the impossibility of an event. Now, if the event cannot take place, that is, if the event is impossible, then its probability will be 0 or 0%. In other words, an event associated with the random experiment is called an impossible event if it never occurs whenever the experiment is performed. For example, the probability that sun will rise in the west is 0. So this is an impossible event. Now, all probabilities must have a value greater than or equal to 0 and less than or equal to 1. Now, this can be shown by a probability scale. Now, the probability of an impossible event is 0. For example, getting a number greater than 7 on a rolling die is an impossible event and its probability is 0. Now, for an unlikely event, the probability is 1 by 4. For example, it will rain tomorrow. Then, for an even chance, the probability is 1 by 2. For example, getting an even number on a rolling die, then the probability of a likely event is 3 by 4. For example, no one will be absent, and the probability of a certain event is 1. For example, getting a number less than or equal to 6 on a rolling die. And now let us define the probability of an event. Now, if in a random experiment there are n mutually exclusive and equally likely elementary events, and m of them are favorable to an event E, then the probability P of happening of an event E, which is denoted by P of E, is defined as the ratio m upon n. Therefore, we can write the probability P of an event E is equal to P of E is equal to m over n, which is equal to the number of elementary events in E, that is the favorable events whole upon total number of elementary events in the random experiment. That is, P of E is equal to number of favorable outcomes over total number of possible outcomes. Also, we will write P of E is equal to m upon n, which is equal to n of E upon n of S, where n of E denotes the number of sample points in E, and n of S denotes the number of sample points in the sample space S. Now let us discuss the working rule for calculating probability. For this, in the first step, we will find the number of elements in the sample space S of the given random experiment. Then, in the second step, identify the elements which are favorable to the event E in the sample space S whose probability is required. Then, the required probability is NE over NS. Now the probability Q of the failure of the event E is given as Q is equal to P of E naught, that is the probability of E naught, which denotes the probability of the failure of the event E. Now P of E naught will be equal to the number of unfavorable outcomes over the total number of outcomes. Now, the number of favorable outcomes for the event E is m, and the total number of outcomes is n. So, the number of unfavorable outcomes will be equal to n minus n. So, P of E naught will be equal to n minus n whole upon total number of outcomes, which is n. This is further equal to 1 minus m over n, which is equal to, now m over n is equal to P of E, so this is equal to 1 minus P of E. From this, we have P of E plus P of E naught is equal to 1. Now, the probability P of an event E is denoted by P of E, and the probability Q of the failure of the event E is denoted by P of E naught. So this implies P plus Q is equal to 1. Now from the definition of the probability of an event, we deduce some results. First is, since we have P plus Q is equal to 1, so when Q is equal to 0, that is when the probability of failure of an event is 0, then the probability of happening of the event will be equal to 1, that is, the probability of happening of an event will be maximum. And when Q is equal to 1, then in that case P will be equal to 0, that is, the probability of happening of an event will be minimum. Thus, the probability of happening of an event is greater than equal to 0 and less than equal to 1, and also Q is also greater than equal to 0 and less than equal to 1. Now, if m is equal to 0, that is the number of favorable outcomes is equal to 0, then in that case, probability of happening of event is 0. This means that there is no event. For example, the probability of drawing a gold coin from a bag containing silver coins is 0, as there is no gold coin. Therefore, the event cannot take place. Now let us discuss the next result, which is if m is equal to n, that is, if the number of favorable outcomes is equal to the total number of outcomes, then in that case Q is equal to 0, that is, the probability of failure of an event is 0 and the probability of happening of an event is 1, and in that case the event is certain. For example, the probability of drawing a silver coin out of a bag containing all silver coins is 1. Therefore, the event is certain. Now, if in case the number of favorable outcomes is equal to total number of outcomes by 2, then in that case P is equal to 1 by 2 and Q is equal to 1 by 2. This means the event is as likely to happen as to fail. That is, in the case when the probability of happening of an event is equal to the probability of failure of an event, then in that case the event is as likely to happen as to fail. That is, the chances of success or failure are equal. For example, on tossing a coin, a head or a tail is equally likely to occur. And now let us discuss the probability of an event not happening. Now consider the case of rolling a die. Now in this, the probability of getting an even number, now let it be P of E is equal to the number of favorable outcomes, which is equal to 3 over total number of outcomes, which is 6. So this is equal to 1 by 2. And also the probability of getting an odd number, let it be P of O, is equal to 3 by 6, which is equal to 1 by 2. That is, the probability of getting an even number is 1 by 2, and the probability of getting an odd number or the probability of not getting an even number is also 1 by 2. Now, the sum of these two probabilities will be equal to 1 by 2 plus 1 by 2, which is equal to 1. So the sum of the probabilities of all mutually exclusive outcomes for any event must be unity. That is, getting an even number and getting an odd number on the rolling of a die are two mutually exclusive events which cannot occur together. And we are getting the probability of getting an even number plus the probability of getting an odd number on rolling of a die is equal to unity. So in general we can say, if P is the probability of an event happening, then 1 minus P is the probability of the event not happening. So in this session you have learnt about the measurement of probability and the definition of the probability of an event. So this completes our session. Hope you all have enjoyed the session.